Homework 3, problem 3a. So, suppose that the limit of f of xy as xy approaches ab is equal to L. Show that the limit of f of the absolute value of xy is, as xy approaches ab, is equal to the absolute value of L. It may be helpful to use the fact that the absolute value of the absolute value of a minus the absolute value of b is less than or equal to the absolute value of a minus b. So, and the rest of this, so we're going to start with this, and then the rest of this, use this to show we need to figure out what we are using. So, first of all, by the definition of a limit, we know that if we have this, the limit of f of x, y as x, y approaches ab equal to L. If we have this, then we know that there exists some epsilon that is greater than 0 such that the absolute value of f of x, y minus L is less than this epsilon, as long as we have 0 less than the square root of x minus a squared plus y minus b squared is less than some delta. So having this, it implies that this is true, or by definition of a limit, having this makes this true. So by this fact right here that we were given, we can show that the absolute value of the absolute value of f of x, y minus the absolute value of L is less than or equal to the absolute value of f of x, y minus L, which, as long as this condition is satisfied, we have already said is less than epsilon. So we are allowed to then say that the absolute value of the absolute value of f of x, y minus the absolute value of L is less than epsilon. Now, by absolute value rules, we can replace these outer absolute value bars by saying that this portion here, the absolute value of f of x, y minus the absolute value of L, is less than epsilon and greater than negative epsilon.